All right, so as we dive into our trigonometry unit, we will start to talk a lot more about angle measure, and we will today talk about two ways to measure angles. One of them we're pretty familiar with, and that's degrees, and the other one will be new, and that's radians. So what is a degree? We know that we can divide up a circle into 360 pieces, and we can call each of those pieces a degree. So if I'm looking here at my circle, you can see that I divided my circle nicely into four. We could call those four quadrants. So we could say that I have an x-axis and a y-axis here. I could say that this angle measure right here is 90 degrees. I could come here and erase this. I could say here that this angle measure here, so here's my starting side, I could call this right here 30 degrees. So degrees is a measure of angle that we should be pretty familiar with by now, and we should know that there are 180 degrees in a right triangle. And over the past week or so, we've been dealing mainly with right triangles. So now we can chat a little bit about what a radian is. So I'll let you sort of take a look at this slide here. A radian is similar to a degree in the way that it measures a central angle of a circle. So up here we were talking about degrees, we were talking about chopping up a circle into 360 pieces and calling each of those a degree. A radian also measures an angle, we could say, in a circle, but the radian measure deals with the length of the radius of the circle. Whereas here, it doesn't matter how large or how small our circle is, right? We could have a very large circle here. We could pretend that's a nice circle. And this angle that I could draw here would still represent 30 degrees. So down here, a radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. So you can see here that I have my radius measure here, and I've sort of taken this length and I've placed it on the outside of this circle, and we would call this 1 radian. And we could come over here. Here I've taken the length of my radius, I've placed it here along the arc of my circle. That would be 1 radius. Placing another radius here, 2 radius, that would make this here an angle of 2 radians, because I can fit 2 of my radius on the outside. So here we can see, let's grab another color here, that this length is equivalent to this length and this length and this length here, except these are, of course, curved as they're on the outside of the circle. So we can work a little bit with radians. So to measure an angle in radians, we can divide the arc, the intercepted angle arc, by the radius. So the measure for theta, my angle here, is the arc length divided by the radius. And let's take a look here. So here, find the radian measure of the angle. So I have a radius that's 8 centimeters and my arc length is 6 centimeters. So I can take 6, divide it by 8, and that's the measure of my angle. Okay, like when working with degrees, we will often say 30 degrees, and we'll denote with degrees here. We don't use any sort of formal label. We call them radians. So here I could say that this is 6 divided by 8 radians. We could call this here we could call this 0.75 radians. So this measure right here is 3/4 of 1 radian. So find the arc length of a sector that has a radius of 5 centimeters and an angle of 2 radians. So I could come here, I could draw a circle, could pretend that this is drawn to scale. It's telling me that my radius is 5 centimeters and my arc, my angle here is 2 radians. Sometimes you'll also see 2 RAD. So this means that I'm fitting 5 centimeters twice on the outside of my circle. So I can use my formula here, or I can say, well, if my radius is 5, I have 5 here and 5 here, so the arc length would be 10 centimeters. Or I can say that 2, which is my radian measure, is equal to the arc length, I could call that A, divided by the radius, which is 5. And to get A alone, we can multiply both sides by 5 here and get that 10 is equal to the arc length, just like we did down here. So how do radians relate to degrees? So when we're talking about a circle, and we will really, as we move forward with this trigonometry unit, use radians and degrees very interchangeably. So how do they relate to one another? How many radians are there in an entire circle? We know that there are 360 degrees in an entire circle, but how many radians can I fit in one circle? So we can think about it as the angle is the circumference divided by the radius here. So my theta could be 2, I know that circumference of a circle is 2 pi r divided by r. So my entire circle here will end up, if I simplify out my r values, an entire circle will give me 2 pi radians. So I can start here, come all the way around, and I'll end up being at 2 pi radians, which means that half of my circle, or 180 degrees, is the same thing as pi radians. And when we work with radians, we will very often, and when I say very often, I think I'll go ahead and say always, we will always work in terms of pi. So moving forward here, I know that 360 degrees is equivalent to 2 pi radians, which means that 180 degrees is equivalent to pi radians. So how many radians are there in an entire circle? So we already answered that question. So here I have 180 degrees as pi radians. We can use this as sort of our conversion factor. So here I could divide both sides by 180 degrees. And I can get here that 1 degree is pi over 180 radians. And over here, I can divide both sides by pi and get that 1 radian is going to be 180 degrees divided by pi. So, and this is what we would come up with for 1 radian is 57.296 degrees. So these are our conversion rules. This is what we will use when we convert from degrees to radians and from radians to degrees. So depending on if we're going from radians to degrees or degrees to radians, we'll use this conversion rule for going to degrees to radians. And we can use this conversion rule going from radians to degrees. So for example, if I had something like 30 degrees and I wanted to convert to radians, I could multiply 30 degrees by pi over 180 degrees radians. My degrees here will simplify out with each other, and I'm left with 30 pi over 180 radians. And I can simplify this 30 divided by 180. So 30 pi divided by 180. We can treat that like it's a regular fraction here. And let's see, we could go to 3 pi over 18. And we could go one step further and call this pi over 6 radians. So I know here that pi over 6 radians is the same as 30 degrees. So thinking about if we're converting from inches to feet or feet to inches, we would use something similar here. So if I had 24 feet and I wanted to convert to inches, I could start with 24 feet, multiply by my conversion factor that there are 12 inches in 1 foot. My feet units will simplify out with each other, and 24 times 12 is going to be what would give me 288. So 288 inches is how many inches are in 24 feet. So it's really similar to sort of dimensional analysis if you've done that before, or it's just a very sort of straightforward conversion rule. So as we move forward with our unit circle, these are some very common angles and radian measures. So 0 radians and 0 degrees, pi over 2. So I'm starting with radians. So I can say that pi over 2 radians times 180 over pi radians. So I'm using this conversion factor right here. My pi radians will cancel. I'm left with 180 over 2, which is going to give me 90 degrees. I already know that 180 degrees is pi radians because that is our conversion factor. Pi over 4, I can say that I have pi over 4 radians. I'm going from radians to degrees, so I can call this times 180 degrees over pi radians. My pi radians will simplify out. I'm left with 180 divided by 4, which will give me 45 degrees. Here, 30 degrees, we already converted into pi over 6. Pi over 3 radians times 180 degrees over pi radians. I have 180 divided by 3, which will give me 60 degrees, and 3 pi radians times 180 over pi radians. My pi radians will simplify out, and I'm left with 3 times 180, which is going to go ahead and give me 540 degrees. And I can see here that this 540 degrees would be more than one time around an entire circle. And I'm hoping that we are sort of noticing here that I have 90 degrees, I have 45 degrees, 30 degrees, and 60 degrees. So as I say that these are common angles and radian measures, that we are starting to make connections between these pieces and our special right triangles and some of the right triangle trigonometry that we've done. So you can sort of see where this is headed, sort of what we're gearing up for. So convert the following angle measures from degrees to radians. So we'll just do a few more examples together. I have 55 degrees. I'm going from degrees to radians, so I'll multiply pi radians over 180 degrees. So this will give me 55 pi over 180. My degrees will simplify out, so I actually won't end up writing that. And we can simplify sort of this fraction, the 55 over 180, as appropriate. Convert from radians to degrees, so pi over 7 times 180 degrees over pi radians. My pi radians will cancel, and I'm left with 180 divided by 7 degrees. So you should be able to go ahead and do the first chunk of your homework. There's a lot of converting from radians to degrees. Feel free to shoot me an email if you have any questions. If not, give that homework a try and work towards the next lesson. Good luck, guys.